Here's where I left off. We were talking about the sphere. We were talking about the. Let's go to another color here for just something new. I was talking about the radiation here. Whoa, that's a eraser. Oh, we were talking about radiation over here. Put some red out there. And these were some of the equations that I came up with there and said the area of a sphere is 4 pi r squared. That's very important, but I think I need to make a correction here. And that correction is you see in this K that N there? Well, for each one of these Ks, there's going to be an N, I'm sorry, an L. Let's call this one an L, this one an M, and this one an N. This K has an N, K sub X has an L, K sub Y has an M, K sub Z has an N. And when we say, I'm going to introduce a new variable called P, and P squared equals the L squared, in the case of X, the M squared, in the case of Y, and the N squared in case of Z. Three-dimensional stuff. Three-dimensional, and we've got these L's all in there, and now we're going to go to a P. And this P involves all of these things. And so what I'm going to do is replace this R with a P. Now, I hope you've absorbed that. This R squared down here is, let's just kind of forget about it. I'm not sure that that's really going to help us do anything. So this N happened to be a K sub Z if we want to add all that stuff up. So if that doesn't confuse you enough, let's get out my eraser. And the nice part is that I'm willing to accept my mistakes. Okay, let's go through here and let's get rid of that. And I guess we'll stick with red for a while because this is the new stuff. Area of a sphere is still up there for grabs. And let's go get my marker now. All right, let's try and recoup what we need to get done here. The thing is that I want to make a relationship between N, big capital N here, is going to be the number of frequency modes abbreviate that. And the modes are going to be indicated by P, which is this letter that I just pointed out was the square root of all these other indicators. Oh, I'm sorry, the integer numbers on the K values. And let's see what we can do here. Let's see if we can put all this stuff together. So the number of modes that are there, and what I'm going to do is put a 1/8. Can I make an 8? Maybe I can. A 1/8 times this area of the, what am I trying to say? This area of the sphere, which is 4 pi P squared. Now, what does this all mean? Well, that's the number of frequency modes, and that'll help us finally come up with some frequency information here. Let's see if I've left anything out. I think that's okay. Now, why 1/8? Well, it's 1/8 because only positive values are counted. Only positive values are counted. So Why is only positive values counted? Well, if you've got frequency modes in the positive direction, let's see if I can go back over to my, I'll go over here and just wiggle this thing around so you can see what I'm talking about. If you only consider positive modes, then that means you're only going in the positive X direction, the positive Y direction, and the positive Z direction, which you can't see here. And if you only include those values, that's only going to cover 1/8 of a sphere. So that's why all this stuff is done here, because we don't want to be double counting stuff or triple counting it for that matter. Now, what's this P thing? Well, let's go back to the K business. We had the K was equal to 2 pi over, whoops, let me get the eraser out here again. The K was equal to, in this case, I'm going to put the P there, P pi over L. Let's see if that makes some sense. All right, let's try to relate this to this squared value up here. So P squared would equal, it's going to be K squared, and it's going to be L squared, because this is in the denominator, so when it comes over there, and in the denominator is going to be pi squared. Let's see if that all works out. Let's see if that works out. Okay. Then if we say dk, now, whoa, that's a differential. What's going on here? If we say dk, then that's going to be pi over L equal, let's put equals there, dp. So let's see how this all works out. This np, what we should have done is put a differential of p up here. So if we look at this differential of p, let's come down here. Differential of p is equal to, let's see, what's going to happen there? That's going to be L over pi dk. I just ran out of space, and my board got a little bit run out of space here. That's going to be a dk. All right, can we make sense of this? Probably not. Let me get the eraser and let's start fixing stuff here as we go. Okay, what we want to do is put this in terms of K and dk. Why is that? Because this has the wavelength information, and this is going to give us our frequencies out of here. So I'm going to leave this up here for a little bit so we can plug that in. There's, oops, I just got rid of my marker. N sub p, the 1/8 is still there. Let me erase that, clean up that abortion I've got here. N, give it some more space. P equals, and now we're going to put this in terms of K. The 4 pi is still there. The P squared is now K squared, L squared, running out of space, over pi squared. You're saying, what's all this about? Remember, we're trying to get to the frequency so we can come up with energy. And let me see what I've got here. There's a p squared. Let me get rid of this thing, get this out of the way. And we want, instead of a dp, we want a dk. And that is the dp was equal to L over pi times dk. I'll put parentheses around that just to kind of show you where things came from. This is the p squared. And the dp looks like this. In place of the dp, we're putting an L over pi dk. Now, let's get rid of that other stuff. So we went from this expression to this expression, and the reason why this is important is this L here is part of the wavelength business. The L is the dimensions of the box, and that determined the number of modes here. Now, don't be too worried about this differential of P, because that tells us what in other words, we're coming up with an expression that we can integrate over. Integration, differentials, blah, blah, blah. Okay, so anyway, where do we get frequencies out of this stuff? Let's see if we can proceed here a little bit further. Lost my marker again. All right, let's do some simplifying here. Between the 4 and the 8, that's going to leave a 2 in the denominator. Put a 2 down there. Between these pi's, well, here's pi cubed, but then there's a pi up here, so that's going to leave us with 2 pi squared. The k squared on the top remains. And we've got an L cubed. And I guess that's it. And that's dk. So let's look at that, examine that a little bit and see if we can make some sense out of it. Well, here's one of the things that we wanted to get to is that L cubed is the volume. That L cubed, L, that gives us the dimensions of that cube. And let's see what we come up with here. Let's say that's, let's put the big V here. That replaces the L cubed. K squared over 2 pi squared. And that's dk. I'm going to stop sharing here for a while and come up with the next installment.